Okay, so what next? Let me go here. And I think we can save this piece. Okay, so the next topic is values that are constants, right? So meaning they are read-only. You can create a variable and it will be read-only. Meaning we can't modify the value. If we try to modify the value, C++ will generate an error and it won't let us run the program. So let's look at that example. I think in Python, you use a capital for the variable and then like hope that other developers honor that's not to be changed, right? But in C++, it's like it doesn't trust us, right? So it'll be like, no, if you can mess up, you're gonna mess up, so I'm gonna trust you. So we can create a variable and use it, right? So I'm gonna create like a constant double, I'll say pi, and then I'll just use some values like 3.4159, right? So this is a read-only variable, and also it is global to this header file, meaning and so meaning any file that includes it can use double, right? So that's what it means. But the key thing for us here is it's read-only, and then our goal here is to show that it is it, right? We're going to create some examples. We go get area of circle, and then we say double radius. And we go to this piece here, make sure we include constants. So can we say pi? So notice pi is here, but I'm like, okay, I want to change you, right? I'm just gonna type whatever. And notice we have that underscore right here, right away. So expression must be modifiable L value. Like L value means a data type that has an address, and we can retrieve that address in C++, right? So that's what it means here. But we can't change it, right? However, we can use it. Like if we say, okay, you don't let me change it, well, I'm still going to use it to do some math operation, right? So let's see here. We'll say auto area equals radius times radius times pi, right? And then we can return area. So notice we are reading the value. We're not modifying it. So then C++ is happy. And this is good. Like if we were doing some math piece, right? Or if we were doing like some payroll, then we could like set the payroll tax value, like the percentage for federal income tax, and read only. That way it can't change, right? Like nobody can go in there and change it. So those are two different examples that we can think of to use this concept of read-only values, right? So, or constants. Questions here? Okay, so we can go to a test case, right? So let's go do a test case. We're still here, so test case. Okay, so let's see here. And we need to include constants at the top. So include constants. So now C++ will know what we're talking about when we want to use that get area. So we go require. Oops. Get area of circle, and we send in the radius, right? So let me see here. What value did I use for my test case? I used the value 10. Easy enough, right? So that should net us 3.1459. We still have to be aware of comparing decimal values to decimal values, right? Like that's a no-no, right? So in this case, we would want to convert both of them to whole numbers. So we would use multiplication, right? Multiply this times something that makes this a whole number, and then do the same thing over here, right? So I'm not going to do that because that's part of some homework assignment in the near future. But we can still see, well, we're going to get lucky, and there's the test case passing. So running terminal. Excuse me. And I guess that's why I use value 10, because that one works, right? So here, notice we have 314.159 and 314.159. So that works, right? But we want to make sure, like, we don't want to do that, right? I purposely leave it like this because in a homework assignment you're gonna have to do that, and I don't want to give you the answer, right? But it's easy, right? You just have to be like, okay, what do I need to multiply this by to make it a whole number, right? And then you do the same thing to the left side, and then you can compare whole number to whole number. However, one of the issues with that is sometimes you might have to like limit the decimal pieces, right? So then you would have to find a function in C++ that allows you to round, right? Round to like the third, what is it? Tens, hundred, thousands to the thousands, right? So I'll leave that for you all. Let me see here. How do you get pi to change into the number again? Not sure. Okay, so not sure what that means, right? But we have pi, right? We say create a double, right? But make it const. Const means read only. Like this value, once our program runs, is persistent. We cannot change it, and we use it here, right? We can use it here because we included constants.h. So I'm not sure how do you get pi to change into the number again? Like I don't understand like the question. And finally, we can use this piece in main, right? So we go here, and then we're like, okay, let's create a small main program with what we know so far. So include IOStream using character input, using character input, using cout, auto radius equals 0, cout enter radius, can't type, enter radius, character input, get the value from the keyboard, save it into the radius variable, new line here. Actually, not new line there, new line here. No, that should be fine. And then we can say auto area equals get, and doesn't know what we're talking about, so that means we need an include up here, so we'll say include constants.h. Get area of circle, radius, and then finally see out that piece. So again, you can use this like for your homework, right? Go to my examples and see how to do stuff. So that's why I provide them for you all. And we can, one more thing, let's add a new line here. Okay, let me run this piece. So run in terminal. Right, so a small simple program to show us. Let me go back here. What is the function of double in that code? The function of double here, remember double means make it decimal, allow it to store decimal values. So double allows us to use decimal values, right? So just remember, float is double is a very large float, and C++ they call him double, and then that's what they call him, right? So that's the function of double here. I'm thinking that's what you were asking, right? Remember, in C++, you have to always tell it what kind of variables you're working with. So here my variable name is pi, and the variable data that I'm using is double, which is decimal values. And const means make it read-only so that no one can change this value while my program's running. Other questions?
Professor, I have a question for the test case.
Mm-hmm.
Yeah, so what I meant by the question about how do you get pi to change into a number, what I mean is how did you get it so that pi, like the pi turns into 3.14?
Yeah.
As a number.
So first thing is we have to create the variable. Okay, so here we create it. It's in constants.h. We're using it in constants.cpp, so we have to include this piece. So this piece allows us to use any code that's in this file. So when we use pi here, it scans our file and understands what pi is, so then this will be 3.14.159.
I understand that. It's just what I mean is that for the test case, what I had it equal to was just pi times 10 times 10 rather than the 314 point.
Here?
Yeah.
You can do that, but usually with test cases, you want to be explicit, right? Like, this is the result I expect. So if I use this, then the result I expect is this. So all the calculations are happening here. You said you did pi times 10 here?
Times 10 times 10.
Yeah, but I mean, you can make a mistake there, right? Like, because you're doing calculations. So what you always want to put here is the end result. That way, like, I mean, you understand what you're doing, pi times 10 times 10, but if you leave and then other developers, like, trying to understand what you did, they're going to be like, what? But usually test cases, the way they work is use some function with some value, and developers know that this is the expected result. And so you don't want to use calculations, because if your calculation here is incorrect, and test case fails, then you're like, okay, this calculation correct? Or is an error in here, right? So then you're creating more area or points for fail, right? And here, like it's always like 314.159, right? So you're like, hopefully that explains, right? So
like I understand that. It's just like what I'm trying to get my head around is how did you convert PI like on the actual code into into pi itself? Like I know how it works. It's just what I mean. How would I get the exact expected number? That's what I mean.
the exact expected number here.
Yeah. Because it doesn't do that for me when I type in pi. It doesn't do that for me. I don't get that.
Well, then use this value here, right? I think you're saying you're using pi here times 10 times 10. I think that's what I understood, but I mean, we don't want to do that, like, so don't do that, right? Let me run it, right? I guess your test case is failing. That's what you're asking, or I'm not understanding.
I mean, well, what I'm trying to explain is that because I'm trying to get the exact expected number, I can't really write down the number that was there before the 314 point something because then it won't be the accurate number or to the code. It fails my test case when I just type it in rather than doing that pi times 10 times 10.
Yeah, well, in that case, that's why I was explaining. Like, if it fails, then you have to convert. You have to like do some multiplication, right? Like convert this guys to whole numbers, and then this guy to whole number, and then because your computer CPU is probably like storing extra decimals. That's why we don't want to be comparing decimals, right? So I was explaining. Convert this value here to whole number, right? In essence, we can just do this. But now we have to find a way to convert this to whole number. And we can convert it to whole number. It may pass, it may fail. If it fails, that means that in here, we need to round. So we would need to figure out how to round to make sure that when it comes out on this end, it's the correct value, right? So hopefully that explains it to you. But that's what's happening. You're running into a decimal precision issue, and that's why your test case is failing if you use this.
Okay.
Yep.
Thank you.
Okay. Let me see here. I think that was it for today. But there is a quiz that's gonna start at 6:50. It's an easy quiz, so let me stop here.